Please pause the video and take a moment to read this important safety message. Hey, welcome back everybody. This will be the first in our series here beyond the teaser video of restoration on the pair of MC30s and the C8 and C8-S preamplifier. Today we're going to focus on the C8 itself. Faceplate's in really good shape. Some of the knobs here have a little bit of pitting going around, but all in all, I think they look really good. Just doing kind of a visual inspection all the way around on this. The sides look good. The chrome on the tops look real good. You can see the mud on the umbilical cord here, and I'm assuming the owner cleaned that up some. But these things had literally been stored in like a building just full of junk over the years, not climate controlled and whatnot. Anyway, you can see on the back here you've got your tape output, your main output, and keep in mind you can either feed out the main output or you can feed out through the umbilical cord over to a McIntosh amplifier like the MC30 that these were paired with. You can see here it has 3 tubes, and these little rubber grommets are to hold the little tips of the tubes in place, and you can simply screw these off and get to the tubes without having to open the whole unit up. Then you have a tape input here, and you have a adjustment on it. You have a tuner input here and an adjustment for it, and you could use this tuner input for say a CD player or something of that nature. Then you got a mic input and an adjustment on it, and then a low-level phono input here, and then another phono here. And on this phono you have kind of an adjustable impedance match on it, so that's pretty cool as well. And then you got some power jacks out the back here that you could use then to power other devices if you wanted to. But the number one thing I'm seeing here, and I don't know how clearly you can see, but this power cord is just horrible. As you can see here, it is just gone completely. Good news is the umbilical cord seems to be in really good shape. So we're going to replace the power cord, but the umbilical cord, thank goodness, because they can be a little bit pricey if you've got to go about replacing one. And we can actually unscrew this right here and take the umbilical cord off. And as you can see here, it just unplugs coming out the back, and it's a typical octal, not optical, octal socket here. So I'll undo that, and I'm going to set this umbilical cord aside. That'll make this unit much easier to work on and move around the bench. That umbilical cord is somewhat clunky. If you'll notice here, this is the audio compensator C8 here on this unit, and it's got a little sticker on it here from years ago. I'll end up removing that, but let's take a look on the inside. To get the tops and bottoms off of these, it's a simple little nut driver with some screws here that will come out, and then it's just a simple matter of lifting these plates straight out and off. And you can see he did a good job cleaning this up here, and you can actually see me in the mirror there. Anyway, whoa, let's take a look here. What am I seeing here? Let's see if you can see what I see. Yeah, sure, you're right. 3 Telefunken tubes here, and if I can look down in there, it's a set of ladder plate Telefunken tubes here. So we will definitely test these out. Hopefully they're still good. Looks like the getters are still strong on them and not gone, but you just never know till you go and test them, because and we'll also look at the schematic a little bit and talk about whether these need to be matched or not. It's certainly not a stereo setup, so you're not feeding left channel into one. Keep in mind, each of these is the twin triode tube, each one of these. So there's really 6 tubes here, okay? 1, 2, 3, 4, 5, 6. And in a lot of scenarios in stereo environments, you might feed the left channel into one side of the tube and the right channel in the other side of the tube. Thus, you want the two halves of the tubes matched very closely, so you're not amplifying one side, your right channel more than your left channel, for an example. But that's not the case. This is a mono amplifier here. Let's see a little more of what we see here on the top end. I see a couple Bumblebee Capacitors here. I see an awful lot of the older carbon comp resistors, and then I see a lot of them down here kind of on the compensation record compensation switches. So we'll end up testing all these resistors the best we can. We'll certainly pull the tubes out when we do that, but let's flip it over and take a look on the bottom. Okay, similar story on the back side of these. Just two little screws here, and these are not 1/4 inch, by the way. They're a little bit smaller than that. And you can just lift this straight out, much like the other one, and then we can, and I'm going to flip camera angles right now. Okay, so this is the bottom side of the unit, and you can see there's a whole array of Bumblebee capacitors. Now, let's talk a little bit about Bumblebee capacitors. Some people cherish these, and they think they're the holy grail of capacitors, right? Because they are what gives a certain piece of equipment their tone, right? And I will not argue that with you. They certainly help define the tonal attributes of a piece of gear, okay? The flip side of that is I'm betting out of this, what we got here, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, plus I saw 2 more on the other side, 21 capacitors in this unit. I'm betting at least 5 or 6 of them are extremely leaky. And what happens when they leak is they cause issues with the circuit because you're putting high voltage then. Keep in mind, that's one of the roles these capacitors play. They let audio flow through them, but they block DC. And so what happens when one of these is leaky, it still lets audio go through it, but it also lets the DC go through it. So you may be putting DC onto another part of the circuit where DC should not be, and causing either components to wear out prematurely or burn up tubes really fast, things of that nature. So, at any rate, we've got some wafer switches here on the selectors that probably need cleaning and whatnot, and we'll go through and do that. But the other big thing I saw here, this great big monstrosity right here, if you don't know what this is, anytime you see one of these with multiple plates, sometimes it'll have 2 wafers, sometimes it'll have 3, 4, or 5. This is a Selenium Rectifier, and the downside to Selenium Rectifiers is they are historical for going out now that they've got a lot of years on them, and when they do, they kind of explode, to be honest, to some degree. Not like, boom, blow your unit up, but they make a heck of a stinky mess. And they can also short and take out your circuit and your power transformer. So it's a good idea to kind of get rid of these units. And if you'll notice, someone has already done that. So I thought these might be all original, but if you'll notice, this unit's been, the tab's been cut off of it right here where I'm pointing at, right here. And you can see right here is the blue tab that they cut off. And what they've soldered in place is 2 diodes in place of this Selenium Rectifier at this point, okay? Now, when you do that, you have a different voltage drop on a Selenium Rectifier than you do with diodes, and you typically have to compensate for that with some resistors changes, but we'll talk more about that a little later, okay? The next thing you've got here is you have a pair of electrolytic, and it's kind of hard to see here that there's a pair. But here and here are 2 large electrolytic capacitors that both need to be changed. These are very, very old and likely, keep in mind, these are electrochemical devices and they dry out over the time. Think of like a 9-volt battery. Over the years, they kind of break down, they leak, and they dry out. Same thing happens with these electrolytic capacitors. And here we have a very large 3, so in other words, inside of this one large can, there are 3 capacitors inside of it. We're going to want to replace that as well, because remember, this guy told me to restore this gear like it was my own. So if it was my own, I'm going to replace all these capacitors. I'm going to go through the unit. I'm going to replace any resistors that I find are out of spec. Now, I'm going to leave as many of these carbon comp resistors as I can in place in this unit, because I think they have some effect on the sound as well. But those that are out of spec will certainly get replaced. I'm going to replace all the caps, though, that is for sure. We are going to replace this electrolytic, these 2 electrolytics. Everything else in this unit, I think it's just a matter then of cleaning up. We certainly want to replace the power cord, as I talked about, and these other two Bumblebee capacitors here. But for everything else, we'll kind of test them out. We'll clean all the pots in these units and whatnot. Let's go over and do a schematic walkthrough, and then we'll build a parts list for what we need for these. All right, let's do a schematic walkthrough, and I typically like to start with the power side of things. If you'll notice, you've got a 117 volt wall outlet. You come in here, you got that historical death capacitor here tied between that and ground. You then go here into a pair of kind of noise capacitors here, and then you've got three outlets, none of which are switched. They're just live, and you can feed other devices out of that if you need to, okay? And if you'll notice, it also feeds into pin number 5 and 6 here to feed another device if needed, okay? Then you kind of have here your set of a little rectifier here, which is that Selenium Rectifier voltage doubler here. And what it's doing is it's basically feeding here a capacitor and then these 3 filaments of the tube. So basically you've just got a little DC power supply here feeding the tubes, or rectified I should say. And then you got the pilot light tied off of that, okay? Okay, then over here, basically, this is the back end of things where the output happens. So let's start back over here on the inputs. You can feed in tape, and you notice it's got a 500K ohm potentiometer here for the adjustment. The tuner 500K, the mic has 100K here, the phono has 100K, and then this phono here, that's where these other things switch in and out, and you have the adjustable impedance match on this. And then all these feed into a switch here, basically a wafer switch, and as you switch this switch here, it lets you select between which input you're feeding. But basically then, if you choose to feed phono, okay, it will come off of the phono sections up here, and it will feed into 3 tube parts, okay? So this is 1.5 tubes here, right? You've got V1A, V1B, V2A. So this is all in one tube glass envelope. This is in another glass envelope, okay? So what you've got first here is you feed in, and you have basically here a voltage stage here where we're feeding out of this up through a 0.33 coupling capacitor. By the way, all this up here is just coming in from the power supply, a capacitor here for filtering, and then your plate load voltage and a little bit of drop voltage here on this tube, and then another plate load resistor here. You're feeding across, you're coming into the second tube here, a little bit more gain, you're coming out of it. It looks like then we're not coming out of the plate, we're coming out of the cathode and feeding over into this rumble filter section here. And what that is that's a cathode follower here. So there's typically no gain associated with that. It's just an impedance buffer here to let you drive higher impedance devices, or excuse me, lower impedance devices on the other side here. From that, you kind of feed out and you come into the treble compensation, your bass compensation switches. So as you flip these switches on and off, it brings in and out different parts of this filter here. But basically, eventually you end up feeding out of that here, down into, through this selector switch, back in this 30.033 coupling capacitor, into the second half then of the second tube, which is V2B, right? You then come out of the plate of this tube, you feed over, and you come into here. I'm sorry, we're coming out of the cathode of this tube with another cathode follower here with a 0.47 microfarad. And if you wanted to feed out to a tape unit, this is where you would take your output. Otherwise, it comes over here, goes through a little bit of a compensation network here for bass, and then it feeds over here into another tube where it does some more amplification, which is then at that point part V3A, the third tube, the first part, comes out of that, goes through a 0.1 coupling capacitor, goes through this aurial compensation, which is nothing more than basically a loudness control with multiple settings. You come out of it, you go through basically the volume knob here, you feed through another coupling capacitor into this tube and out of yet again another cathode follower, which feeds to pin 2, which feeds over via the umbilical cord into the next amplifier. Or you could also peel off of here and go to the main out and feed something besides a McIntosh amplifier. I'm going to leave it at that for now. That's the general walkthrough of how this unit functions. If you notice here on this schematic I downloaded, down here at the bottom, what does it say? Serial number 10600 and up. There are several variations of this unit. So unless you know for sure you've got the right schematic, I would match up your schematic against what you're actually reading in the unit when you go to build your BOM or build the materials for ordering your parts. I'm much more likely to go with what's in the amp than what's on the schematic in this case. All right, I was starting my my notebook here of parts I needed, and I happened to notice in the mirror reflection here of this little plate down in here, there's a Bumblebee capacitor that's right here underneath the Selenium Rectifier, and you can't really tell it. Let me see if I can get a little light on it. But the entire side of this capacitor right here has been blown off, as you can see. Okay, I said there were probably 5 or 6 bad. One is definitely on the list already. Okay, what we're doing at this point is I'm just kind of working my way left to right here with capacitors, making my list of what I need here on my paper. And I started to put into this video all about how to read Bumblebee capacitors, right? And then I realized I'm going to have to do the same thing in each of these videos. So I made a separate video about 6 or 7 minutes long, just on how to read the values of these and some common tips around them. So please go watch that video and then come back if you're not familiar with how to read the value on these capacitors. But all I'm doing at this point is going through. So like the first one I figured out was a brown, black, orange, white, yellow, and I went through and I figured out I had 4 of those, and that's a 0.01 microfarad. I've realized I've got 2 of these 0.0047s, and I'm just going to keep going down the list, working my way left to right, and don't forget there's a couple on the other side. But I'm not going to drag you through that, but that is what we're doing. Okay, what I've done is I've got them all written down now, and now I'm going to pull out my handy dandy chart and go through these real quick and just make sure I get them all right here. Another double check I will do, because you'll notice as I came through here, I was kind of working left to right. I made sure I write down quantities if I ran into any of these capacitors more than once. But just a safety check on that, you can always go through here and count them. And if I go through here, okay, that's 19 capacitors on that side, and there are 2 on this side. Just run down your math real quick over here then. 4, 2, that's 10, 10. Yeah, we're at 21 here on this side as well. So we've got the exact same amount added up on both sides here. All right. Let's get all these figured out, and what I'm going to do from there then is start testing resistors. Okay, as you can see here, we got them all worked out. We've got our quantities and our values here now that we need. And also, don't forget, there is a little electrolytic right here in these units. It's 50 microfarads at 6 DC working volts. So when you see 6 DC WV, that stands for working volts. So I just wrote down 150 microfarad at 6 volts. That'll likely end up being a 47 microfarad at probably something like I'll put in a 20 or 25 volt. But because 50 microfarad is not a common value, and you'll be fine with 47 microfarads right here. All right, let's go through and measure resistors, and then I'm going to come back and get these caps here. But once I pull them out, it'd make it harder to flip the unit over. So I'm going to go ahead and get the resistors. Now, one thing you got to take in mind when we're measuring resistors in circuit, sometimes the resistor doesn't have any other components in parallel with it, which would affect its resistance value being measured across it, and thus you're okay just dropping across a component. One thing to definitely do is pull the tubes out of this unit, because then you'll move any inner workings within the tubes playing out with measuring resistors. But sometimes you'll measure a resistor and you'll get a value and it doesn't align up at all. And so that probably means there's something in parallel. You can go look at the schematic and figure that out or not. If so, you always have the option of lifting one end of the capacitor up, snipping it, lifting it up, measuring it, putting it back down, and soldering it back in place. But we're just going to go through this unit kind of one by one here after we've pulled these tubes out and see how close we get. I will tell you, on a stereo unit, it's a little easier than a mono unit, because a stereo unit, like I could measure this value right here, and it might not be what the capacitor reads, but that's okay because I know something else is in parallel with it. But I could then also look over here on the left-hand channel if this was for the right channel, and I could measure the one there. And if the one on the right-hand channel matched the one on the left-hand channel, then they're probably good to go. You know, you always look for imbalances, but when a mono unit like this, you're stuck pretty much measuring these units. And the good thing is I don't see any that are black and charred that have been burned up. I did find that one capacitor on the other side that's popped open, but we'll kind of take it from there and start measuring. Okay, to get the tubes out, there's just 4 little knobs here on the back. You'll pull all 4 of these off. And then this little plate here. Whoa, about to lose one. About to lose another one there. This little plate comes off and easy to access the tubes. That was one of the beauties of these, is you could pull these tubes out without ever having to take the unit open. Okay, these tube sockets are tight. I'm just having to wiggle this ever so slightly, kind of move it around, finally get them out. Alright guys, I'm going through and I'm checking, and I'm going to give you an example of what you see, especially on some of the higher value capacitors. Like this capacitor right here, right? Orange, yellow, silver, right? Should be a 330K capacitor. But what we see here is 347.2K capacitor. And that's what happens with these older carbon comp resistors, is they start drifting up in value over time. And for me, if they get outside of their tolerance range, right? So in this case, we've got a silver capacitor here. We're at a 10% tolerance. If you get out of that, so 33%, we're still within tolerance here. But if I get outside of that, that's when I typically look at replacing it. And the reason I say that is this capacitor from the factory could have been that number. But some people like to get these as close as they can back to the original values. Now, once I get the amps restored and I hook them up in a stereo setup, if I notice any imbalance between the two, I would start chasing it down, and capacitors that I kind of note that are a little, more than 5% or so out of spec might be subject for those things. But otherwise, I'm going to try to leave it as original as possible, and that is a subjective kind of topic I've got there. Some people would go through here and put 1% resistors in every place here and try to make this as precise back to the original schematic as possible. And in doing so, they might just affect the overall tonal attributes of this amplifier, and it might not sound like a McIntosh C8 at the end of the day. Still might be a great amp, but I'm trying to keep as much of the original sound here as I can. I would do that with the caps, other than they are likely bad, and even if you test them good, they could go out on you tomorrow. So, I'm more likely to leave resistors in than capacitors. Okay, we kind of went through all the resistors here, and I didn't have but a few out of spec that were ones I had subject. I may try bringing the amp up without replacing them because they weren't very far out of spec. And we'll see how it does, and I can always drop these in if I tell there's any difference between the two amps, or if I measure voltages way off from where they should be, if that makes sense. Up next, we're going to pull this capacitor in these. To do this, I'm going to have to pull these screws off here, and these you just pop out. They're a little bit of a pain now, very, very tight. Okay, up next I've got the Telefunken Tubes. I'm going to test them one at a time here in the E-Tracer tube tester. So let's go over and see the results. Okay, I've got the tube in there. I've turned the heater on. I've let it warm up now a good 2 or 3 minutes. And we're just going to run a quick test against it here. And what that does is it kind of finds the operating point of where this tube should operate, and it'll move forward and back about 5% on that. You'll see the 5% swing numbers here. And so what we've got here, if we come over here and look, we're actually in really good shape. Plate current on these, we're at 101.6% and 102.7%. So this tube is fairly well matched from a plate current standpoint. And then if you look at micromos here, we're at 104.8%. In other words, reference is 1600 for a new tube, and we're measuring 1677, which means we're at 104% of what a new tube would be. And then if you look over here on the right section of the tube, keep in mind, dual triode, two tubes inside of every tube, we're at 109.3. Well, if you subtract that from this, you get your about 5%, a little less than 5% delta here. So this is an amazing, wonderful, good tube that tests like new. So we're definitely going to put this back into this amplifier. All right, let's test the second one here. Little different results. You notice the red lines and green lines are not completely overlapping here. In this case, we're at 85% on current on one side, 97% on the other. And if we look at our kind of gain figures here, the micromos, we're at 90% on one side and 86 on the other. So still not bad, not perfect. I'll take a look at where I would place this in the circuit versus the other one if I decide to keep this one. All right, let's test the third and last tube in this unit. See what we get. Not so bad. Okay, we're at 119% on one side, 102% on the other. GM wise, we're at 115 and 109. So this tube tests new plus. I will likely end up using this tube, and honestly, I'll definitely end up using this one. The second one that was a little bit weak, honestly, a little bit weak Telefunken, I would probably choose over a new strong or a new tube, newly manufactured tube, I should say, that tests new any day of the week. So I think we'll end up keeping all three of these tubes in the unit. It'll save the seller some money. Plus, he doesn't have to invest a ton of money in getting the vintage sound out of these old Telefunkens if you buy into such a thing. All right, and here we are just removing this final little screw right here so we can get the cover off of this and figure out what we've got hidden behind door number one here, capacitor wise. Okay, we got this plate pulled off. While I've got it, I'm going to go ahead and get this other side here. I'm going to get this Selenium Rectifier taken off and get it out of the way so it's not in the amp anymore. Okay, and both of these are 2000 microfarad at 15 working volt DC that we're going to end up replacing. These are some old Cornell doublers. Anytime you see these capacitors here with kind of a fiber wafer end on one end here, or rubberized, and the other end with a metal end like this, they need to go. These capacitors, this was made in the 12th month of 1957, if that gives you a clue. That's 10 years older than me, and I'm not doing so well health-wise myself, so these are definitely in need of replacement. Okay, on these type capacitors, they're a pain. You just have to kind of work them up with a screwdriver underneath and kind of roll them out. But eventually they will come, and you can kind of, you got to be careful the leads are still connected to them. But we can read this here, I do believe. We've got 20 microfarads at 450 working volts, 30 microfarads at 500 volts, and 30 microfarads at 250. We'll see if we can find a replacement for that. Okay, so we've got it wrote down now, and I was wrong when I was reading it out a minute ago. It's 120 microfarad at 450, a 30 at 300, a 30 at 250. And if you'll notice here, I did write down the dimensions on it. It's 2 inches tall. So at that point, we've got our full BOM made out for what we need to order or go pull out of stock for restoring this unit. Keep in mind, I'm going to go through this other unit, likely to have to double all these. Okay, here we are with the C8-S unit, which is a great companion for the C8. And the reason being is it kind of starts to play the role of master and the other C8 will play slave. And what I mean by that, the reason they called this the C8-S is it is a stereo pass-through unit. So what you've got here, if you'll notice on the C8, you've got the bass controls here and the treble controls here. Well, here on this unit, they've ganged them up here, front and back, via a front and back potentiometer, so that you can control both from this one knob. It freed up space here on the unit to add this, which is basically two things. It's another ganged setup. One of these is your kind of selector switch between stereo, mono, reverse, that type thing. And the other then becomes a balance control left to right for stereo. Similarly, they have ganged up the volume pot here, so you're doing the volume for both left and right channel when you do that. Now, everything else about this unit is just like the C8. It is for one channel. It's a mono unit. But as you can see here on the back of this unit, you've got the ganged up balance control knobs here. You've got, if you can see down in here, you've got the ganged up volume control knobs. So what's happening is this preamp here is sending a signal through one of these gang pots and another one and back out. The other comes from the other unit, feeds into this unit, just kind of passes through these controls here and then back out to the amplifier. So it's just a nice way of having kind of a master control. The other difference that this unit has is this connection right here. It's a headphone jack. So and it's pulling both left and right channels that are feeding through it. You know, it's picking up one as a pass-through, so you could listen to stereo headphones. Outside of that, this unit is exactly the same as a C8. It's got the exact same capacitor, although it's been turned a little bit to make room for these input jacks here on the back. If you'll notice, this unit still has the original Selenium Rectifier in it, and it has not been taken out of play. It is still in use right here. Still got the two 2000 microfarad voltage doubler capacitors here. This board down here is identical to the what's in the C8. You can see here the little 50 microfarad at 6 volts. So from a parts list standpoint, because we're likely not going to be swapping out any of these ganged pots here, it is identical to the other use. And if you flip it over on the other side, you'll notice I've got the same two Bumblebee caps on this side, the same resistor lineup, had the same 3 tubes here in the back. I pulled them out, although slightly different. These are all original Telefunkens, as you can see, but these are all smooth plate Telefunkens. So we'll leave them in this unit for sure. Outside of that and the additional jacks, and you can see this, just like the other one, the power cord on this is completely shot and in shambles here. It's just, you can see it there. It is gone. But the good news was the umbilical cord was in great shape. So I'm going to go through the same process. I'm planning to replace all the capacitors so I can build a bomb based on the other bomb I've built for that. And I'm just going to go through now and do like I did last time and test resistor after resistor. And I'll likely end up with a few different ones that need to be replaced than in the other unit. And we'll kind of take it from there. So, you know, clean the knobs and whatnot. Oops, and I had a washer rolling around in here I need to put back over here, but you get it. It's really not that much different other than a few places for circuit to feed in, go in here, get controlled by some knobs and feed back out over into the amplifier for the other channel. Alright, let's go back to the bench. Okay, let's test the 3 tubes in the other unit and see if we need to replace them or not. Yeah. Well, good news is testing strong, 117%, 135%, 13% GM, 122. Not exactly matched, but this is not a stereo unit, so if I place this properly in the circuit, this will be a great tube to use. All right, we'll test the next one. Now this is significantly different, okay? You notice one section here, 124%. The other section, 68.9 on current, 114% on GM, and 78% over here. So not a very well matched tube, and you're starting to get kind of down into the weak zone over here. So we'll likely talk to the owner about replacing this tube. And let's test the third and last tube in the unit here. Much better, 107%, 114%. We're at 170%, 114% here. So this one's in really good shape, and percentage-wise, balance between the two, about 7% difference between the two sides, which is well within what we would need for this unit. Anything under 10% in a stereo unit is what I'm shooting for. In a mono unit like this, where one stage would be following the other, not in parallel left and right channel, you can kind of look at where you place tubes and circuits and be in a much better shape with mismatched tubes than in a stereo unit. And last today, I thought I'd leave you with, there is a manual out here that you can find online, and I'll try to post it on my website, that does show you how to hook this up, the C8S. It talks about how the C8, the little bit of modification you need to do to it. It's basically, you need to remove a pin from your umbilical cord by snipping it off. And it'll walk you through what you need to do there as far as that goes. And it'll tell you how to jumper between the two. And some of it has to do with serial numbers before or after. And then it tells you how to interconnect the C8S and whatnot. So just so if you end up with two of these, there is a good manual out here to be had that shows you how to do all this. All right, and there's also here a separate C8S schematic that shows the ganged pots and the kind of how the audio flows through this in pass-through mode. So I will try to get this on my website for you as well. All right, last here, I just thought I'd show you the BOM I made for one of these units, because it's pretty much the same for both, plus or minus a couple resistors on each one of them. But what we've got here is a bench fee. I charge $45 just to do the general inspection. So basically what I've done in this video was the bench fee, or was the bench check. So at this point, I'm at a place I can stop, order parts, and if customer says move forward, do the restoration on the unit. And if they move forward, I waive that bench fee. One power cord here, 21 coupling capacitors. That's going to take some time. One rectifier circuit rebuild. So even though this had some diodes in one of them, the other one didn't. And I want to replace the diodes that are in them with some newer, faster diodes. And I want to make sure that the voltage is right. I may end up adding a resistor in line for that. I ended up having to replace 5 resistors, one can cap, and it is okay. I looked on this one. I looked at the schematic really well. Instead of a 30-30-20, I'm going to use a 30-30-30 in this case, and that'll be absolutely fine. And then we've got the 200 microfarad at 15 volt capacitors, and then I put down 3 hours of labor. I always like to quote, what the most I think it might take to do something. If I get in here and it only takes me, usually like if I'm doing 2 units, the first one will take me 3 hours, the second one might take me 2.5 hours. Well, I would reduce the final bill when based on that when I charge the customer. So what I put here was it includes a bench test, cleaning of switches, potentiometers, etc., testing tubes, replacing coupling caps, replacing power supply caps, rebuilding rectifier circuit, replace out of spec resistors and other components, bias the unit if anything needs to be done there around that, and bench test. So we'll get both these bombs off to the customers if they want to move forward while we work on the bombs for the MC30s. I like to bundle things, and that's why I start multiple projects at a time. That way, if I need to order parts, I can consolidate orders and save on shipping across multiple repair jobs here. So, at any rate, stay tuned. Part 2 of this video will be the actual restoration of these units.